All right, let's talk about an area of exceptional preservation a little closer to home. Yeah, the cat's looking at me. So this is the Mazon Creek area, which is found in Illinois. But apparently, if you're from this area, you call it Mazon Creek. Yeah. So yeah, I don't know. Yeah, I'm clearly not from the area. I'll still say Mazon, but yeah, this is an area where we have extraordinary preservation of soft tissues and from a wide range of animals and plants, and they are marvelous fossils. And we have a good collection of them. So let's take a look. So this is in Illinois, and at the time it was laid down, which is in the Carboniferous. It was very near the Paleo equator. You can see it running basically right through Illinois, which is really something to think about now, isn't it? Yeah, Illinois, equatorial. Wow, yeah. And you can see that all of the North American plate has tilted in that time because this is running at a pretty strong angle compared to where the equator currently runs. And so there's the equator. Texas was a little south of the equator at this particular time. So yeah, things have changed a little bit. All right, so let's look at it. And so there is a variety of pits. So this area was mined for coal for a long time, and these leftover sort of coal pits are still there. Pit number 11 is the most famous one, where you get some of the best fossils, and some of these other pits. Like I want to say pit number 9. I thought that was a good one, or maybe it's 8. Yeah, we'll see it here just in a minute. Yeah, all right. So the Mazon Creek, used to be in an area where there was a delta, and so you'll have a lot of these formations. The Francis Creek Shale is going to be the sort of dirt that was laid down on top of a lot of really compacted plant matter. And the plant matter itself has gone on to form the Colchester coal, which is just underneath. So they were mining through this area in order to get to the coal, which was just under it. And essentially, we're dealing with stuff that's in the waste rock above it, including the Illinois state fossil, Tullymonstrum gregarium, I think is its name, the Tully monster to you and me. And it's a weird looking thing. We'll give it its own episode here in a little while, its own lecture. Yeah, so you had a lot of stuff coming from the land, which would include some nutrients, but also sediment and stuff like that. And we got a fan delta where it's fanning out and being deposited along here. Think like the bottom of Louisiana, the big delta there, something like that. Within this formation, you will find nodules. And here is a nodule. These are made of siderite, and siderite is an iron carbonate mineral, so FeCO3, iron 2 carbonate, and it's the thing that has that pinkish appearance, like pinkish gray rock. It forms little crystals. That's when it's slightly oxidized. It looks a little bit pink. And so we have a bunch of those, particularly ones that have plant fossils in them. You'll probably recognize them now. Yeah. And so these, iron carbonates, siderite, make these little nodules. And the nodules must form very fast. Like before decomposition can really set in, the nodule has formed around it, or the thing has been preserved inside. And then once that happens, you get great preservation of everything, including the soft tissues. So there's going to be a thing called the braidwood fauna, and these are going to be both land and sea organisms, things that have been living in the swamp and got washed out, so the washout organisms. And then you'll have the Essex fauna. These are going to be near-shore marine organisms. So most of your plants and leaves are going to be in this area. It'll be rare, but like when you get something like a spider, the spiders will be coming from the land, and so they'll be in this shallow deposit. The marine organisms, which mostly end up being one kind of sea anemone-like creature called Essexella asheri, those are going to end up in the middle here, and you will find different accumulations of these things in different pits, is the idea. But yeah, there's a depth gradient, and you get different fossils at different points along the gradient. Yeah. Now, within these formations that are producing the fossils, so here's a little spider that fell down. We think there is a step-by-step process that's going to be described here, and we can go through it in class. The Francis Creek Shale is going to make concretions that are pretty abundant in pyrite. The problem is, with the more pyrite you get, the less fossilization of soft parts. Pyrite's great for preserving hard parts, and at least the pyrite in this place did not do a good job at preserving soft parts. So the concretions are more abundant, and they have more soft tissue preservation over here. And there's actually a gradient. So the farther you go from shore, the more it turns to pyrite. The nearer to shore, the better chance you have for siderite concretions with a bit of iron in them. So here are some siderite concretions, and they look great. So here's one with a little fish in it. Here's one with a big trigonotarbid spider-like thing. Here's a whole bunch of plants down here. Yeah, there's all kinds of stuff. Yeah, most of these are only labeled in terms of what pit they're from. And some of these pits have areas where you would have great preservation or terrible preservation, where you would have lots of concretions or no concretions. And some of these pits are massive. They cover a really broad thing. So saying which pit is from isn't always very helpful. Yeah. Here's the Tully monster, Tully monstrum. And so this creature is this creature. See this little bar? It's called the bar organ. And these things on the side, those are actually its eyes. This sort of proboscis up here ends in a little toothy snapper. This is something. So it's got teeth at the front. It can possibly be a predator. Yeah, crazy. Or go down and pick on little bits of dead things. Strong swimmer. You got a nice long tail here. You got muscle blocks where, as this thing is drying out inside the rock, it's going to sort of split between those muscle bits, just like you see on the inside of a fish stick if you ever open one up after you cook them in the oven. And this would also, not to give too much away, have some interesting things running down the center of it. We'll get to that later. Don't worry about it. Yeah. Here are examples of some other Mazon Creek fossils in these nice little siderite nodules. So the siderite nodules are going to have these great little plants. Annularia is what you call it when they're arranged in little circles. Some of these actually are named different things, but come from different parts of the same plant. So before people were sure, just to be careful, they would name each plant piece that they could describe separately. And it's only later that they've tried to figure out which ones actually belong together and form the same organism. So it's one of those cases where you can have an organism with several names for its different parts. Yeah. Here are some terrestrial arthropods. So these are from the near shore side, where you get the excellent soft body preservation. Here are great trigonotarbid spiders. Look at those things. These are massive, sort of beefy bodied spiders. Here's a gigantic spider-like organism. And you've got things like dragonflies, things a little bit closer to a cicada, things more like myriapods of different sort, things like centipedes or millipedes, for example. But all of this from the Carboniferous, so from the relatively late Paleozoic. Yeah. The most common fossil in the marine layers at Braidwood at the Mazon Creek is this guy. It's called Essexella, and it's a little, it's got tentacles on the top. It lives mostly burrowed into the ground. It's got sort of bumps along the side and kind of a ring at the bottom. It's something like a little sea anemone. It's a cnidarian, and there are separate papers that I think very effectively describe what this is. Here are some other cnidarians. So this is the little tentacles on an acanthomedusa. And these are considered to be traces from the insides of jellyfish or an entire cnidarian jellyfish. which is certainly very possible. Unfortunately, with Mazon Creek, you will get preservation of some of the soft parts, but it's often as a very thin, sort of like a film, and it can be quite fugitive. Like when you open it, you can lose it pretty easily. And also, they don't sometimes crack along the place where you want them to crack. And so, good preparators, if they figure out that they have something worth studying inside, will actually excavate the fossil out rather than just waiting for it to crack open. Plenty of annelids and mollusks, including lovely little bivalves down here, and a variety of little annelid worms. You would call these maybe polychaete worms, although that term used to be just a reference to sort of worms with hairy parts on them. Now that they've done actual family trees of the annelids, those turn out to be spread out all over the place on the tree. And so it's not a term that has any real meaning anymore, but it's a term you may be familiar with, so that's why it's there. But yeah, they're annelids, that's for sure. Do we have arthropods? Not a lot, but we have some. So in addition to those spiders that we saw earlier, or they're trigonotarbids. These are the things that are about to become spiders. They have a lot of spider-like parts. They have a little triangular head, which is just amazing. They're not trilobites, or not spiders yet. You've got big sea scorpions, eurypterids by the look of it. You've got relatives of horseshoe crabs. Xiphoceurids is what those are called. You've got relatives of different kinds of shrimp and things like mantis shrimp, for example. And yeah, all preserved in there. So pretty cool. You've got chordate fossils. So these are all different kinds of mostly fish, you would say. But also, oh, is that a Tully monster on the chordate page? What? How did that get there? And there's another one, and there's another one. I don't know. We're going to have to study more about this to decide if we can believe this. But notice the fish eyes. The actual soft parts are mostly gone, but there is a black residue right there, or in some cases you have a little white powder, which is what remains of the bones. That black residue is right where the eye would be. I wonder what that could be. I wonder when that's going to come up in a future lecture. I don't know. Here is, there's your holy grail right there. Siderite concretion in situ in the Francis Creek Shale member, which is where all of the Mazon Creek organisms come from. So yeah, crack it open, maybe a Tully monster inside, and those things go for thousands if they're relatively complete. Yeah. Good looking creature, whatever the heck it is. Yeah. All right, so that is Mazon Creek or Mazon Creek, and we get concretions. The concretions are made of siderite, which is an iron carbonate mineral, and it's going to preserve the fossils very excellently and with mostly molds of their soft parts. So you'll get soft things preserved, but it'll be like an external mold of the soft thing, as opposed to something like Chengjiang, where you get all different minerals injected, and you'll get actual internal and external preservation, but all the hard parts will be gone. So you never get everything you want with a fossil. That's for sure. That's definitely for sure. All right. Thanks very much.